Okay, some one-sided limits and the corresponding limit. Now let's look at number 1 first. So I'll do a table of values to sort this out. So I'll have x as one column, and then 1 over x as the other column. Now x is going to 0 plus, so I'll choose some increasingly small numbers for x that are positive. So I'll go like 0.1 and 0.01, 0.001. Now when I invert these numbers, I get big numbers. Okay, another way to think of it is if you have 1 over 0.001, that's 1 over 10 to the minus 3. So I get 10 to the 3, which is 1,000. Okay, so I look at what's happening here, and I can see that this list of numbers here is getting bigger with no ceiling. Okay, so this is going to infinity. Okay, so I'd write that the first one-sided limit is plus infinity, or just infinity if you want. Now if I'm doing number 2, the same idea, but now I have negative numbers, so you'd have the same chart here, but this becomes negative, and the 1 over x becomes negative, and you're going towards minus infinity. So we get minus infinity for the number 2. And then the overall limit is going to not exist because these two things, number 1 and 2, do not agree. So we just write d and e. Okay, you'll remember that the overall limit exists if and only if the two one-sided limits both exist and agree. Next, how about this guy? 1 over x squared. What's happening here? Okay, so I'll need to look at the two one-sided limits. So if I do the x going to 0 plus to begin with, what do you get? Okay, one way to do this, it's kind of a notational thing. You can just take this 0 plus and plug it in here. This notation is a little bit strange. If you don't like it, you don't have to do this. But so what we're saying here, or what we're trying to imagine here, is that 0 plus is a very small but positive number. So if I have a positive number that's close to 0, and I square it, what do I get? Well, I get 0 plus, don't I? I get a small number that's positive. And when I have a positive number divided by a very small positive number, what happens? Well, we just saw this above, where we had this chart here. Okay, when we invert a small number, we get a big number. Okay, so this again here is, so that's going to tell us what to do here. So 1 over 0 plus is going to be plus infinity. Okay, the notation is a bit strange, but what we're saying here is when we write down 0 plus, we're thinking of a infinitely small positive number. Now if I do the other limit, the left-hand limit, I get the same thing. Oops, I made a mistake here, not 0 plus here. I want 0 minus. I want 0 minus here. So if I just plug it in there, I get 0 minus squared. Now if I take a very small negative number, so 0 minus is a very small negative number, and I square it, what I get is a very small positive number. You know, think about 0.1, negative 0.1 squared. You know, I'm going to get plus 0.01. Okay, so once again I get plus infinity for my limit here. Okay, another example to eliminate this. Oh, geez, what did I do? I forgot to do something up here. Okay, so I did the right-hand limit, I got plus infinity. I did the left-hand limit, I got plus infinity. So my overall limit is plus infinity. Okay, now this guy. Let's have a look at the two one-sided limits. So if I go 2 plus of x over x squared minus 4, what do you get? Well, we'll plug it in. 2 plus over 2 plus squared minus 4. Okay, so what happens here? 2 plus. Now here, 2 plus, what is that? That is a number that is slightly bigger than 2. So if I square that, I get something slightly bigger than 4, right? Now, if I have something slightly bigger than 4, and I subtract 4, I hope you agree I get something slightly bigger than 0. Okay, so now I have 2 divided by a very small positive number, or infinitely small, so I'm going to get plus infinity here. Because I got, well, the division by 0 tells you you're going to get a plus or minus infinity, and positive over positive is positive. Okay, next one. The left-hand limit. Is going to be 2 minus on top. Plug it in that fashion. Now on the bottom, if I have 2 minus here, that's something slightly smaller than 2. When I square it, I get something slightly smaller than 4. And if I have something slightly smaller than 4, and I subtract 4, I get something a little bit negative, right? Now here the notation gets a little strange here. When I write 2 exponent minus, what I mean is something a little bit smaller than 2, but that's still a positive number. Okay, so 2 minus is a positive number. So I got positive divided by negative, and that's minus infinity. Okay, so again, because 2 minus is like, I don't know, maybe you want to think of it as 1.999. That's still a positive number upstairs, but on the bottom I got like negative 0.001. Okay, what do we find? These two things do not agree. The right-hand limit does not equal the left-hand limit. So my overall limit up here does not exist. Okay, one more thing about this notation. Let's do a side example here. If I gave you, say, limit x goes to 3 plus of x squared minus 2, let's say. So you could just use this scheme again, where you just plug in 3 plus. Oh boy, what's happening? Okay, we're back. You can plug in 3 plus minus 2, and then you get 9 plus minus 2, and that would appear to be 7 plus. But the point I want to make here is that this notation with the exponent plus, that's just a temporary notation we use to help us find these limits. Okay, I'm going to say that again. What I've done here and what I've done here, okay, I'm using the exponent plus notation just in my intermediate steps. Okay, my final answer should never have a exponent plus or exponent minus. Okay, it's just something we use to help us resolve these limits.